Second lecture, uh, second interactive session. In the previous interactive session, uh, we left some questions to be done by the students. Was if like okay doable? People, what are the questions? What are the rules? And then let's do one thing. Uh, Let us start with the next uh, uh, interactive session. And if there are some questions, you can listen. So, second week lecture. So, in the second, we are trying to study about three-phase diagram. Three-phase diagram is a very basic way of thinking about this is like we can say this is the most elementary way of thinking about how soil will behave. What basically we think about is that soil is a granular material, and the difference between soil and or a porous material uh, and a solid material is that the porous material will have voids. Uh, as discussed last time, somebody rightly pointed out that E has to be greater than zero because at E equal to zero, your material will stop being granular and it will convert to a solid. That is the definition of solid. So, by virtue of this definition of a porous material, we know that at elemental level, what will happen is that soil will have some solids and it will have some pores. So, if we see like this, right now there are two phases present in the soil. This is the dry form of soil. So all pores are dry, there is no water in the pores, and uh, there are these solids. When we talk about some index properties, for example, when we talk about specific gravity, we are talking about what is the density of these solids. So it means that in a representative element volume, if you take the unit volume, how much space only that volume that is occupied by the solids you are taking, volume of solids and weight of solids. So the solid density will be weight of solids by volume. And then your specific gravity is the density of the solids divided by this density. It does not depend upon what kind of packing the material has. For example, we talked about void ratio, maximum void ratio.
Ma'am, you are not audible.
In field, you can have we do compaction, for example, we run rollers over soil, we do aeration of soil so that the packing gets closer but it has nothing to do with GS. GS is a fundamental property of the material, but actually is like that it is, we can say that at a molecular level, that each grain of soil, how heavy it is, how much material is packed in one grain without the words. So, as I was saying, that in a dry state, we will only have two phases, that is solid and fluid. And fluid in this case will be air. And if there is some water content present in the soil, we will have another phase which will be water, and this will be the three-phase diagram also. Now, there are two cases in which we will have a two-phase diagram. One, the soil is completely dry, in which we will have only solid and air. Other is when the soil is completely saturated. In this case, we will have only solids and water, and in between we may have this kind of state in which there are three phases present. So at the fundamental level, I am saying that
Madam, can you hear our voice?
what you do with the soil. For example, when you are compacting the soil, you are uh, talking about what is happening to the void ratio or what is happening to the voids. For example, when you study compaction, you say that we are expelling air from the voids, that means we are arranging the particles in a tighter formation. So what basically we always monitor is the void ratio. It's one of the most important properties. And so okay. So, whenever, whatever we do with the soil, we are thinking about what changes we are making to the voids, the depth of the void, the size of the void, volume of the voids, what we are changing. Because this, in principle, in classical soil mechanics, uh, this does not change. Your volume of solids will never change. Your weight of solids will never change. It will always be fixed. Whatever you are doing, you are compacting, you are compressing, you are consolidating, anything that is happening, only this void such as. So, anything this diagram classically what we do is the so this will be the volume of voids, this will be the volume of solids, this will be the total volume, and let us say your void ratio is equal to volume of voids over volume of solids. For unit volume of solids, your P will be equal to volume of solids. Then you can say unit volume of solids and P times volume of solids. The total volume will be 1 plus T, which is called specific. Okay, just a moment. I got a message that I am not audible. Am I not audible? Okay.
Hello, madam.
No? Audible?
Hello. Any others? Can you hear my voice?
Yes, yes.
Then what happens, madam? Unable to observe.
I think everything is on. Speaker, everything.
Okay, then. Thank you. Yes, madam. Now I got your voice.
Now everyone can
Yeah,
hear
just
me?
now. Just now. I am able to hear you, madam.
Okay. Can everyone else confirm that you can hear it?
Actually, I have re-entered by logging out. That's why maybe I'm getting back.
Okay. Ryan Kalvis has texted that you can hear. Okay.
Yeah, even I have tested, madam. Even I have tested.
Yeah, yeah. No, no.
Then
What I mean is just now. I
okay,
would like some feedback from future people that can tell me that yes, I am audible now. Okay, I'm very sorry for this. I did not know that I was not audible. I was
it's okay, madam. That's why we send messages continuously.
okay, okay. Very sorry.
It's okay, madam.
What I can do is I can retrace what we were
You could,
discussing.
yeah, you can ask them to once again re-log in, madam. There is a
Yeah,
possibility of it will resolve.
anybody who is having some problems, who's having any problems with audio, you can leave and join again. I will send this message.
Yes, ma'am. Yeah, I will also make the comment directly oral message.
Okay.
All the students, if you are unable to hear the voice of the madam, I am getting now. If you are unable to get the voice for your side, you can relog once again. You can also pass the message. Yeah,
Okay. Moving
yeah.
forward,
Yes, madam. Did you pass the maximum contents or only one or two slides, madam? Something
just
we could not see.
just
Why?
can you see my screen?
Yeah, I have seen your fabric. You have written structure and something from there. I am able to see.
Okay. No, I was just discussing the sales diagram and what we do for
Okay,
daily space to do. I will
okay,
discuss it again. So what I was saying is that okay, everybody can mute their mics. So so what I was saying is that this is the most fundamental way of thinking about soil types. This is the food that you can like in physics, for example, we try to think about the free body diagram. It is like we simplify it to the food and then try to understand what are the cells that are acting in different directions. So this is like that free body diagram for soil. What we do is we assume that not like I can say. So what we do is like last time we discussed that void ratio has to be greater than zero. Why that is? Because if void ratio is greater equal to zero, or at any time when voids are equal to zero, your material, which is a particulate material, which is a granular material, will stop being granular and it will convert to a solid. And by virtue of this property that you define a particular material by the definition that it has to have voids. You go to this phase diagram, you will say that a representative volume of this material will have solids and it will have voids. This is the basic. So anything that we do with the soil, we compact it, we consolidate it, vib- vibration, rolling, anything that we are doing, we are uh, assuming that only thing that is changing is the volumes. These solids, the volume of solids will be constant, the weight of solids will. Uh, so technically, there can be sometimes of soils, for example, you can have an organic soil that may be there. So in that soil, what will happen is slowly the solid particles may uh, be converted into liquid or gases, and then we will have a lower weight, a lower volume of solids going to solid. But in classical soil mechanics, we always assume that the soil solids will have constant volume, constant weight. That is why your property of specific gravity is basically a very fundamental property of the soil. It is the property of the grains actually. It is not something that will change as you migrate it. It's like you will have a stiffer formation, you will have a denser sand. It will still have the same specific gravity. If you have the same sand in a looser configuration, your bulk density will change. For example, for dense material, your total weight by total volume will change. It will be lower, it will be higher for dense material and lower for loose material. But your GS will always be constant unless and until there is something happening like decomposition, a different kind of process that is happening. So, as I was saying, that at fundamental level, whenever we are studying compaction, we study consolidation, that we will study. We will study permeability. Permeability, we are studying the characteristics of the void such that the how much uh, fluid it is letting the material pass through. And compaction is still again the rearrangement of voids. Consolidation is still again the rearrangement of voids. So there are two cases in which you will have only two phases with soil. One case is when the soil is completely dry and when you have air there. Other cases when it is completely saturated and then we have water. And for all the rest of the cases, you will have a three phase in the soil. So, which which you have the solids, you have the voids. Some of the voids are filled with water, some of the voids are filled with air. So the next thing I was discussing was what we can think about insurance comparing different parameters. One of the main see, for example, I have two soil samples and I want to compare them. There are some properties I will not uh, wish to compare them. For example, bulk density. Because as soon as I got the sample from the lab, I got the sample from the field, I can compact it at any density. It can be uh, the same soil can be compacted and the same soil can be used. But if I have two different deposits, for example, let us say that this is red soil This is black soil, black potted soil. So I will compare them with their specific gravity. It will tell me more about the nature of the soil. Um, so I will compare them with the soil. Okay. Yes. And for the initial conditions of the soil, how much compacted or how much the soil is. This will be the volume of solids. This will be the volume of fluids. Let me assume that I have taken this representative element volume and I have said that let me take this configuration as void ratio, let this void ratio. Let in this configuration volume of solids is 1. For a unit volume of solids, so in the check of that, because other people are really studying. Okay. For the unit
I
volume,
sent the message, madam. Already I kept a message for them.
okay. For the unit
Ma-
volume of solids,
Madam,
yes, yes.
can you use a dark color pen, madam? It looks a black color light. I don't know why. You have option?
Is this okay?
It's also light only. It is coming, madam.
I can do one thing means I can. So, is this okay?
That is better, madam. It's better still. Yeah, yeah, that's okay, madam. Good.
Okay. So for a unit volume of solids, your void ratio will be volume of voids over volume of solids, and volume of solids into as 1, your P will be volume of voids. Then you can say that the volume of the volume of voids, and this is 1. This is a representation. The whole volume of this RDB will be 1 plus E. For specific volume. Yes. That is standardized ways, standardized methods in which we like make formulations in research. Uh, because he will again tell me about if I tell you what's P, if I tell you what's gamma, P, gamma, P, you will know about the soil. But saying that easily standardized way is good. We talk about gamma, HGS, we talk about V, or specific volume. So void ratio, uh, yes, please, yes,
Madam, here specific volume.
yes,
On the right hand side, it is a 1 plus void ratio.
yes.
Void ratio has no units, therefore, what could be the units of the specific volume? Is
The
it going to be no
volume is
units?
also important.
Okay, okay. Thank you, madam.
So, so void ratio in itself should tell you that what it is trying to tell you is that in your REV output, if you have a soil, if you take the unit, uh, if you take the unit sample from that sample, how much volume is voids and how much is solids. So void ratio will be volume of voids by volume of solids. It is not total volume. Total volume is porosity, as you could say there. See there, when we talk about porosity, we are basically talking about limited sample deal with porosity in field mostly, and in lab we talk about void ratio. So A is your void ratio and N is your porosity. We can simply say that N is equal to the volume of oil by volume of solid plus volume of oil, then get this formulation. So the phase diagram, the specific gravity we talked about, it is the ratio of the weight or mass in our three-phase diagram. Our specific gravity will be, if this is the volume of solids, and this is the volume of voids, where E will be volume of voids over volume of solids, and C will be weight of voids, weight of solids. So, yeah, solid density is weight of solids over volume of solids, and the specific gravity is the comparison between weight of solids, density of solids, and water. So basically, when we are talking about specific gravity of 2.7 will that it is 2.7 times denser than water. Uh, not particle, not the porosity way, because you know that water is contained, but the particles of this material are 2.7 times denser than particles of water. That is why you will have soils that have a higher density, higher specific gravity. Higher specific gravity you will see in soils that may have iron in them, metals in them, take specific gravity of particular materials like mine tailings. Mine tailings are just, I can say, for example, we extract there are some metals like iron and copper, which are found in open pits, as in they are mixed with the soil. They're like if you want to extract these, you extract the soil and when you do the process again. Do the process. It's not like something that you will mine out of the ground. They are just mixed with the soil. Then you process. After processing, the soil that you will have less, it will have higher, will have that. So it will have a higher GS. Why? Because the metals will have at particular level higher density. So gravity of most soils range between 2.6 to 2.75. This is the two-phase diagram that we talked about. The dry soil partially saturated soil and completely saturated soil. And the degree of saturation, now if we talk about ASR,
Madam, are you comfortable when I ask a doubt in between?
yes, yes,
Here, some question, madam. In the early part of the soil formation, uh, we studied about how the granular material is formed and how the clay particles are formed. So, clay particles are formed due to chemical weathering. We studied this one at the beginning.
yeah,
So, in the weathering process, actually, the material is transforming into some other new material in which minerals are also changing.
yes.
In that case, if the minerals are changing, how the specific gravity of the clay is a constant?
Yeah, you have to understand that this working process is, it will take thousands of
Okay,
billions of years. So even in our lifespan in 100 years, there will not be enough change in the property of that material. And I'm not saying that the material does not change since the dawn of time. We can say that the material at in my lifetime, if I take a for example, its properties will not. Okay?
okay. For short period, indirectly, relatively, you don't have a change.
Yeah.
Over a long period, maybe there will be some changes.
Yeah. Very, very, very long period.
Okay.
Okay.
And
That's not
another
the
question, madam.
yes,
Yeah. And another question is, as you mentioned earlier, in organic soils, solids are going to be decomposed.
yes,
Therefore, this is like a short period.
yes, yes.
In organic soil, is the specific gravity is a constant? It is going to once again variable.
It is going to wait.
It is going to vary.
Yes.
Okay.
That
Right.
I mentioned that because we are studying classical soil.
Okay.
There will always be a number of assumptions that we are taking because if we don't take these assumptions, all the calculations and all the formulations become so
Complicated.
complicated that you will not be able to make out something very intuitive from it. So one of the assumptions in classical soil is that if the soil is involved, okay,
Okay.
so this after that, when we study about topics like organic soil, peats, as I said, the vine tailings, we are more inclined towards the research aspects, the fields in which research is being done. Okay, so next thing is we are talking about degree of saturation. Now, degree of saturation means that within the voids. See, I don't want you to just uh, remember all the formulae without having an intuitive idea about what exactly it is. Degree of saturation wants to tell you that among from the voids that are present, how many voids, yeah, the amount of voids that are filled with water. So in this we don't talk about VS. We only talk about voids. So degree of saturation will be one when all your voids are filled with water, uh, and degree of saturation will be zero when you don't have any water in your voids. So it is more about telling you this is important usually in the hydraulic properties of soil. So it talks like it is more important with the network of pores, um, what percentage of the pores is filled with water and what percentage is filled with air. So degree of saturation is 0 to 100. Then we have density. Density is very straightforward, but you can have different concepts based on your like. Don't think about different kinds of density. Just think about density of soil in different situations. For example, I'm taking a sample of soil, and firstly, what I will do is I will measure its density in natural state. So in natural state, it will have some solids, some water, and some air voids. So my gamma, I will call this as volume, will be weight of solids plus weight of water divided by weight volume of solids plus volume of water plus volume of air. And now I'm taking the soil, and what I do with it is put it in an oven and completely dry it. So I will have a dry state. Let me call this gamma T. Now I will not have any weight of water or volume of air. It only have, uh, I can say that this is volume of solids by volume of solids plus volume of voids. The gamma D will be weight of solids over volume of solids plus volume of voids again. Then in the third place, what I will do is I will saturate it with water. I will completely fill all the voids with water. This is the same soil. It is goes to say that it just depends on the condition of the soil you will find it to feed. So your gamma saturated will be volume of solids plus volume of water divided by volume of solids plus volume of water again. Okay. Then one more case scenario is there. I will go and use this target to do that. So what this exactly means, it's not like you're trying to round something. It physically means that in feeling, sometimes you come across the water table. For example, this is where lake. You will have water table. So this situation where your sample is below water table. That this has to be in atmospheric pressure. This sample will be a submerged sample. We will take this as gamma saturated of this gamma saturation because there is a point which acting on this soil. No matter if you have a soil there which is saturated. So you can say that The saturated soil will also have water in its pores. It will have the same void rate. It will have the same two-phase diagram. But what will be the difference? The difference is that now this is below the groundwater table and it will have a void force acting on it. Any sample that is above water table and saturated, it will be gamma saturated. But any sample that is below water table, it will be saturated, but it will also have a void. That is what we mean by gamma submerged or submerged density. Is this clear? Okay. So this is the formulation of this is the formulation of the Gaussian wave. This is the most standard definition. S equals E. So we can arrive at different densities for same sample from here. How we know that in dry case your water content or your saturation will be zero, and your gamma D will just be your bulk weight, but now this is zero, which is the conductor. G gamma W 1 plus E into your dry density. And for gamma saturated, your S will be what? So your gamma saturated will become G plus E over 1 plus E gamma W. Isn't it? And for submerged, you know that gamma submerged is gamma saturated minus the force of buoyancy, which is gamma W. So it will be G plus E minus G minus 1 times gamma W over 1 plus 2. Okay. So these are all the formulations. I just did not want you to try to learn these formulations without understanding the idea behind GS gamma W plus E. And we have a buoyant unit weight of saturated unit weight minus the unit weight of water, P is minus 1 level of plus 2. Then we can arrive at all the relations, gamma bulk. If you know the gamma bulk and the water content, obviously from film diagram we will be able to calculate the gamma dry. But easier way is like you divide the gamma bulk by 1 post of two. Okay, this is a very important relation. S times D is equal to W times CS. So what this is doing is basically it is relating the volumetric and the gravimetric parts. Like if I say that I have a volume of soil, it has a volume of solids, volume of void, I give you everything. But now I tell you, give me the weight of this soil. You will not be able to give me the weight unless I have to know the G. And when you know the G, you can convert it from volumetric to gravimetric. And this is a key relation that converts the volumetric, for example, volume of solids is volume of water, sorry, saturation is volume of water by volume of voids. E is volume of voids or volume of solids. And then your weight of water over weight of solids, and then your GS is gamma S. So you see all the weight terms are here, all the volume terms are here. What you are doing is based on this gamma S, how much mass, how much volume does uh, unit mass of this particle, uh, uh, how much it occupies, how much volume does the unit mass of particle occupies, and then you from these to convert the volumetric to the Campbell and Poisson. So one more thing we can have is air content. Air content is we can say like it just tells you about the air content in the complete sample. It's not per volume of coils. It's not like degree of saturation. Degree of saturation is volume of water over volume of coils. We can have um, so now we can move on to some numerical problems. Okay, so we will consider in next class. So let us do some numerical problem. Next up. Let's see. Okay. So the first thing is derive the expression for saturated unit. So saturated unit weight, sorry. We just saw we know that gamma saturated equals weight of water plus weight of solids over volume of water plus volume solids. Okay. So one side we will have weight of solids, weight of water. On the other side we will have volume of solid and volume of water. So this will be a complete volume. Gamma is weight by volume. Void ratio will be volume of voids by volume of solids. And here GS is gamma WPS is volume of weight of solids over volume of solids. So volume of solids equals weight of solids over gamma WPS. Volume of oil equals E times volume of solids. So volume of oil equals weight of solid into volume of solids. This will be the volume of voids. And then gamma saturated will be weight of solids plus weight of water over volume of solids plus volume of voids. But volume of voids is E times Vs. So volume of solids plus V times volume of solids, that will be volume of solids, 1 plus V over weight of solids plus weight of water. Weight of solids over volume of solids plus weight of water over volume of solids divided by 1 plus V. Gamma saturated will be weight of solid over volume of solid is gamma S plus we can say weight of solids by volume of solids is equal to volume of weight of solids is equal to gamma S times volume of solids. Okay, so you can say volume of solids equals weight of solids over gamma S. And equal to gamma S plus weight of water over weight of solids equals gamma S over gamma. And gamma saturated will be gamma S plus this is another subject and there is gamma S over gamma plus B. Gamma saturated will be gamma S times 1 plus W. You know that GS is equal to gamma S by gamma W. So we get the place this gamma sat which is equal to 1 plus W divided by 1 plus B. So that will be 1 density actually. So gamma B, we understood that GS was 1 plus W divided by 1 plus B. We can write W, GW is equal to ES and W is equal to EL by T. So gamma B equals ES plus EL by T. Gamma 1, gamma 5. Basically, what we can do is we can take S here also. What we will do is GW equals E and W equals E by T. So we can do here 1 plus E by T, 1 plus E. And if we multiply all throughout, this will be GS plus E, where the gamma plus E is the gamma. That is the derivative for it. But I hope you understood it is not just playing with the formula, but kind of trying to understand how from gamma boil we can go towards gamma particle. What is the volumetric and what is the gravimetric relation between that? Okay, next question. Okay. Go to the next question. Voice, for example, following example. The total that is for phase diagram as we go. So the sample is moist. That means that it's not saturated, it's not dry. That we will have three phases. We have solid, water, and mix. The total volume is 1.2 liters Total mass, that is, total volume is 110 meters. Total mass equals mass of solid plus mass of water. This equals 2350 kg. Moisture content is liquid. Specific is mass of water divided by mass of solid. Specific gravity is 2.79, which is mass of solid over volume of solid by gravity. So first we need to determine the void depth of the bulk density. Bulk density is simply total mass by total volume, which will be 2350 over 1.2. It's possible with the cube solid. Can somebody calculate this?
1958, madam. 1958.
958.
8.33.
Okay. Now we will try to calculate dry density. We will calculate dry density in all these things in two ways. First, we will simply take the mass by volume approach. Second is we will take the formula approach. So here we took mass by volume. Gamma D will be the mass of solids by mass of how we will know the mass of solids is that we know that mass of water plus mass of solids equals 2350 and mass of water by mass of solids equals 0.086. So mass of water times mass of solids. So this will be 1 plus 0.086 times mass of water equals 2350. Can somebody calculate the mass of water from here? Okay.
2163.
Mass of water is
2163.9.
3.9 and the mass of solids will be total mass minus we subtract from here
186.
186.
Yeah.
So you know the mass of solid, you know the mass of water and your dry density with the speed mass of solids by total volume. And can you calculate this? kg, no?
186
More,
is grams cubic meter.
how much is this?
There is a units, when different units will come here.
What?
186 is a grams, no?
No, no, no. No. It was kg only.
It's kg. Okay, okay, okay.
Yeah,
Sorry.
kg only. 2350 minus
Something wrong is come.
63 is 186 kg only. Yeah.
Something wrong somewhere.
Yeah. There. We have
Somewhere we need to catch.
2350 kg over 1.2, which is 1958.3. So gamma P is correct. Weight of total weight, total volume. Then we calculated mass total equals mass of solid plus mass of water, and water content equals mass of solids, sorry, mass of water, solid, mass of solids. So we will have mass of water equals 0.086 mass of solids, and this is correct. We're not wrong anywhere. It's for put water. 0.086 mass of solid equals 2350. So the mass of solid equals, okay, we were writing it as mass water. 213.9 kg is the mass of solid, and the mass of water will be 2350 minus 2163.9 equals 156.1 kg. And then we will calculate the gamma drive, which is weight of solids over total volume. This will be 2162.9 over 9.2. And how much is that? 2162.9 over 1.2. This is 1 8 liter liter. some red, this, absolutely, and one vessel. From this information, we will not be able to exactly determine the void ratio until this CSS given. Um, this let us do one thing. Let us try to calculate gamma 2. Okay, let us calculate the void ratio. Void ratio, volume of void over volume of solid. We can say if the void is total volume minus volume of solids over volume of solids. And volume of solids we can determine from G equals gamma S over gamma W equals rate of solids over volume of solids times W. And we will have volume of solids equals rate of solids over G W. We already have calculated rate of solids. We have this G and gamma W. Let's take that. And we will if the
0.50.
is clear how we got the void ratio. Calculate the porosity. Porosity is quite simple. Instead of uh, Also, volume is more like total volume. So instead of 0.8 there, we will have 1.8. Including 1.6 minus 0.8 over 1.8. This will be become next thing is we want to calculate the degree of saturation. Degree of saturation tells us the quantity of oils that is filled with water. So this is volume of water over volume of oil. Volume of water we can simply know by uh, gamma W equals weight of water over volume of water. If we know the weight of water from here, from that, volume of water will be 156.1 over 1,000 will be 0.1. Volume of oils was after or sorry, elected.
23 point. Excuse me, madam.
Yes.
Degree of saturation somewhere you are getting 46, madam. I don't know, some error. You can use the formula GW is equal to SC and check it, madam. Once GW is
Yes.
G is known to you 2.71.
2.71.
Water content is given 8.6%. S is unknown.
Yes.
S is unknown. Void ratio is a 0.5. It comes around 46.61%. VW is correct, madam. VW, what you have done is correct. That is a F question. Question number F is VW.
Yeah, we have already done that. Let's check.
Only VV we need to check once again. How you got 0.8?
Calculate.
That's also correct, madam. VW is correct. That's a cubic meter. That's in cubic meter. VV, how you got 0.8? From where you got 0.8?
Let's compare now. volume of solids.
But it's VV, you have taken 0.8 now.
Yeah, volume of solids. Uh, total
Volume of
volume minus volume of solids. Okay, you have take 0.2 is there. Total volume minus volume of solids. We have to take the 0.2 here. Yes, because this is volume of voids here. We will taking volume of solids. So this will be 0.1861 over 0.2. Volume of voids, Mr. Mike. See,
somewhere subtraction.
volume of voids equals volume of total volume minus volume of solids. This will be equal to 1.2 minus 0.8, which will be equal to 0.4.
0.4.
So this will be 0.4. So 0.1861
Now
over,
it matches.
yeah,
Now it matches.
yeah. We were
So
taking the wrong volume. We were to take 1.2 minus 0.8 there.
now
It
it's
was volume of voids. So the formulation was correct, just the numbers were wrong.
you can change the answer, madam, here. 23.26 you can erase. It is a 46.52. Done,
Okay.
madam.
So, okay. So this is if you take the hard-coded values from this, but another way is we can calculate using the formula like we just did. You will know the gamma B equals uh, G S gamma W 1 plus W over 1 plus E. You know the W, you know the G, you know the gamma B, you know the gamma W, you can calculate E. And then for N, you can calculate from E divided by 1 plus E. Then for the other stuff, degree of saturation, you can use WG equals ES. And dry density, you can do gamma T equals gamma V over 1 plus W. So these are the two ways of doing it. Either you have all the formulas in your mind, or you can calculate it from your three-phase diagram. How much was water and what was all these quantities. Okay. Let us take a 5 minute break if it is okay.
Okay.
Let us give me time. We continue. Velocity, acidic gravity, moisture. Determine the mass of water to be added to a 10-meter cube or a volume of solid for full saturation. Let's try to understand this question. So we have a soil sample and we know the volume of the sample. Just use it by one and round. If we draw a two-phase diagram of this or three-phase diagram, we will have some volume of solid. We have some solid, then we will have some volume. Uh, so because the water content is 12%, that means that there is already some water filled in the voids. There is already some water filled in the voids. So the question is asking us that we have been given the porosity that we will know the volume of voids with respect to the volume of solids. We have been given the gravimetric property GS. We will know the moisture content is given with respect to this. So we need to calculate how much water for saturation. We can do one thing. From N, we can calculate P. What formulation for S is equal to GW. We can have S. If there is just it. Enter. Six, eight, six, 0.4. So 48% of the voids are already filled. So how we need to fill 52% of the voids. So the volume will be 52% of VV. But for that we have to calculate VV first. Volume of voids we can calculate, we know the total volume. We can calculate from E 0.67 equals volume of voids. And let's do that from N, it is here. N is equal to the volume of voids over total volume. Porosity is 0.4. So total volume is uh, 10 meter cube. So the volume of voids, total volume of voids will be 0.4 into 10 equals 4 meter cube. So S is equal to 0.48 means that 48% of this volume is already consumed by water. This is just an intuitive way of thinking about it. Obviously, you can use any formula that you like. There are more than 100 ways to solve this. But intuitively, we will have N is equal to volume of voids over volume, total volume, 0.4 equals volume of voids over 10 meter cube. So volume of voids equals 4 meter. And from GW equals PS, we calculated S. That means volume of water over volume of voids that is already present, which was 48%. Calculate. Already at W 18%, 1.92 meter cube of void space was filled with water. How much we need to fill now is 52 times. 52% of the cube. We need to fill 2.08 meter cube of voids with water, which means how much volume of we have? Mass of water. So the mass of water will be simply gamma W dW weight of water. The weight of water will be this into 1000 because the weight 2086. Okay,
Yes, madam.
so this was clear.
Yes, ma'am.
It does make intuitive sense to everybody. Like uh, this is coming under the phase relationships. Basically, we're taking the soil and then we are generalizing it, saying that some of the volume of this soil is held by only the solids, then some by water, then some by air, and then we're trying to use these very basic arithmetic operations to calculate these properties. Okay. Okay. An embankment with a crest width of 25 meters and a height of 50 meters. Size room for notable is what is happening is to be constructed for the embankment. For the embankment, the gamma required is we want to make this a bath. And you see, when you get the soil from this bath, it will be like loaded in trucks and everything. It will not have a particular, it will be loose deposit. So what we do is we lay the soil and then we apply these rollers of this. And then we compact the soil to a particular desired density. The density is similar, but if the greater the density, it kind of directly proportional to the strength. So soil coating management was to be brought from a borrow. So we have a borrow tool in which we are excavating and then using this soil to make the cement. Soil at the borrow tool has following properties. E is 0.68, EF is 2.68, W is 10%. Determine the volume of the soil from the borrow tool that will be required. Construct embankment. Let us say thousands, hundreds of kilograms. Okay. So the first thing that we want to see here is that these are the natural properties of the soil. It is how it is found in nature. There was a site which had a soil with a wide ratio of bismuth, layers of bismuth. Then we excavated the soil and we constructed an environment. Now we can have a distinct void ratio which one has a full time value. It will be the same GS because I said that this is a fundamental property. And we can change, we can change the water table because the void ratio is same what okay. So because we know that between the soil and between this soil, the GS will not change. Let us try to equate both conditions to GS only. First, let us calculate how much volume this embankment will have. So it will be volume equal to quantity time. This is 25. This is 100 to 2 column after. So this will be 30. Will be 30. Is it correct?
Yes, madam.
So
82,500.
five,
500 cubic meters.
five. This is the volume of the environment. Now, what is given to us is the bulk density. We need to compact the particles such that the bulk density is 17 kilojoules. The bulk density is equal to total weight over.
Excuse me, madam.
Yes.
This oil is not mentioned, it's a bulk density, madam, because water content is not given. For
Uh,
Borapit is given 10% water.
yeah. We will
Uh,
assume that we will be making this at 10% only.
Otherwise, we can assume this value 17 as a dry density, madam.
Yeah, we can do that as well.
Yeah. It will be easier calculations.
Okay. So the gamma D
17.
is 17 kilometer per meter cube. Okay. So gamma D equals weight of solids over total volume. From there, we know that the weight of solids that we require is gamma D times total volume, which is 17 times 8 to 5 W0. That's what is it's 1, 5. This is the weight of solids that we require. Now we will go to the test quantity and we need to calculate the volume, total volume of soil that we have these many soil solids. Because it will not be like CS times like we can't just convert this weight into a volume by simply taking some kind of a density to the weight between weight and volume, we multiply and try it out. But here we have to take into consideration that there are some oil, there are there is some water content, which will the total weight that we need will be greater than US air because some of the weight will be from the water. Okay, so GS has been given, which is 2.68. We know WS. So GS equals the weight of solids over volume of solids. You can write this as 2.68 into weight of solids we take from here. Volume of solids will be
Madam, why you have used 1000, madam? Yeah, because weight of the solids is in kilonewton, no?
yeah, stand
Yeah.
out. Sweet and good. So volume of solids will be times to our E has been given as the relationship. Okay. Calculate the velocity equals E divided by 1. Equals 168 divided by 1. Time volume of solid times the 26 volume volume will be the total volume will be volume of solids plus volume of liquids. This will be volume of solids time plus this will be volume of solids into 1.06. Five five 8902. But to think of it more intuitively, what we can do is we know the gamma byte here. Do you know the gamma byte here? E G W. Okay, you know the E, G, and W. You can calculate. the gamma point interfering was G 1 plus W gamma W by M equals 2.68 1 plus 1 making person for the 1 plus 2. So the total 2.68 equal 1 into 10. The gamma pulse here is 7.1 and we can calculate the gamma drive equals gamma 1 divided by 1 by 40 equals 17.5 divided by 1. So 17.95 is the dry density. And the more dry density is equal to weight of solid over total volume. So the total volume required is the weight of solids that we calculate with 12 moles after 0 then calculate 0. Eight seven. The same value. We are going to get the same value from the two methods. Gamma 2. Is the gamma bulb correct? Right? Is it gamma 2 divided by 1.5? Okay. And from here, as we calculate the volume will be with the solid level gamma 2 and 0.06. So let's take about C when we were using the formula where we made the split. So 0 take out W0 to calculate the VS Okay, fine. W0 divided x f. Okay, fine. W people from the 8 and total volume. Seven and 7 yeah, this is correct. Just method. This is the volume. This is the volume that we will require of the soil from this border pit to make this amount at this density. Is the question clear for everybody?
Yes, madam.
Any doubt? Yeah, I will share this slide. You can try to do this question that is left because I think the time is up. Just one question left. And this one left. You can get this out. For a given sandy soil, liquid density actually this actually does not belong in this. Yeah, I think that is it for today. This does not belong there. I think that is it for today. Okay.
No homework, madam.
Okay.
Do you have any question for homework?
Any questions?
Do you have any question for homework, madam?
Okay, for homework.
Any left out you can give us. We can solve and we can discuss also.
Not as such.
Okay, madam. Then it's okay.
Okay.
No problem. Yeah.
Okay.